start. Okay, that's what is optimization. It's application of the derivatives, and optimization means that we will have a word problem and we have to find an optimal solution. And sometimes the optimal solution is, for example, like maximizing something, maximizing areas, maximizing volumes, profit, yeah? Or let's say minimizing distance, time, cost. And that we can see maximizing, minimizing. That means it's almost nothing new, because what we have to do, we have to find a maximum or minimum value of the function. But of course, we will have a scenario. We have to build a function and we have to read and decide if we have to maximize or minimize. That means I do have some steps to follow. Okay? That means all of the steps are exactly the same like for the word problems. We have to read and understand the problem. If we could, we can draw something. We can draw a diagram, some picture. Always when you have a diagram, introduce the notation. Okay? Label, like put X, Y, Z, height, length, width, yeah? Any labels, of course, respectively to the given question. We always have to identify what is given and what they're asking for, given and required information. And then we have to read carefully, maybe even one more time, the whole problem, and determine if we have to maximize or minimize thing, item, yeah, in this problem. And then we have to write a function, okay, in terms of one variable, because we will probably have lots of labels, lots of variables, but we have to find a function in terms of one variable. Okay? And then this will be my function that I'm gonna maximize or minimize. In order to rewrite in terms of the one variable, we will always have some connections, some relations, and we will get this formula. We will see. Always state the domain, because we have to know like what is our like field to move. Like let's say we're talking about the length, the width, we can't have negative numbers, right? For example. That means probably domain will be like a common sense. And then in order to find the maximum and minimum value, we have to, of course, differentiate, because we remember, in order to find max, min, we have to differentiate, find the critical points, determine whether these critical points are maximum, minimum, and then looking at the comparing with the domain, we have to find the absolute maximum, minimum. Testing using the first derivative test or maybe the second derivative test. And then always at the end, come back and check what was the question. Because doing all of the steps, we may like forget, oh, did they ask for the length, maybe for the width, or maybe for the entire area or volume, or whatever we can create the scenario. That means always make sure, especially for the multiple choice question, because the option that we have to choose, we have to know what we're really looking for, what we're answering. Okay, and let's see. I have few problems. Self-assessment quiz will also give you some ideas of the type of the question, and of course this session. That means I'm sure you will have no problem on the actual test, the weekly test, the weekly quiz, and the midterm. This is just the first derivative test. We remember if the derivative is changing the sign from positive to negative, we will have like function is increasing, decreasing, maximum, and then respectively minimum for the other situation. Yeah. Okay, and let's see. That means I have a first question. Let's try to solve it. Example number 1. An open rectangular box with a square base is to be made from 48 square feet of material. What dimension will result in a box with the largest possible volume? Yes, can you see the largest volume? That we do have some information, okay? And we're looking for what? Can you tell me? Are we gonna maximize something or minimize? Yeah, we have to maximize, because it says, because we can see we will use different terminology. We will not say, oh, find a maximum value. No. We have to maximize a volume. That's when we have to find the formula for the volume just in terms of one variable, and then find hopefully maximum. Okay, what I will do, I will put labels x, and h, because it says that is the square base. That means this doesn't look like, but it's x and x. Length times width is equal, and then we have height. That means, first of all, what we have given information is surface area, right? 48 square feet, because the material that I can build the box, it's the surface area. 48 square feet. And then, I should maybe ask you, but okay, I can show you. We need also, like, we have the value 48, but we have to connect this value to the formula, because I have to have some relation between xh and 48. That means surface area, of course, is the bottom, which is x times x squared. And 4 of these sides are the same rectangles. Length times width, or base times height. X times h, 4 times. And since the rectangular box is open, we do not have a top. That means just 1x squared. Okay? And the required information is volume. We have to maximize the volume. Okay, maybe I can ask you now, do you know what's the formula for the volume of box like that? Yeah, it's just the rectangular box, length times width times height. Thank you. X times h. Yes, thank you, Ryan. Thank you, Lizzie. It's just x squared times h. Really good. Because we know what is length, width, and height. Okay, that's we can see what's happened. We do have a volume, the formula for the volume, x squared times h, but we don't like these two variables. We have to rewrite in terms of 1. That means always, please remember, the given information will give you this idea. Because I can say that x squared plus 4xh is 48. And I can solve this equation for h. Subtracting x squared from both sides and dividing by 4x. That means this formula, 48 minus x squared over 4x, will go here. Okay, we have to replace h, and then I have a function just in terms in terms of one variable. One thing it's important. Okay, I have this, and I can simplify. Let me maybe do maybe just like that. I can definitely simplify this function, because x squared and x from the denominator I can cancel out. That's what I did. And avoiding a product, I can multiply x times 48 and x times x squared. And I did even divide by 4. Okay, I hope it's not too fast. X times 48 will be 48x. I can write it down. 48x minus x times x squared x cubed over 4. Okay? But 48 divided by 4 is 12x, and x cubed over 4 will be just simply 1/4 of x cubed. And that we can see is just because I did completely avoid a product rule and not really quotient rule, because we have constant in the denominator, but sometimes we can get like confused by this. That means now we can nicely see we have nice function, no product, no quotient, because we know what is the next step. We have to differentiate. Before we differentiate, one thing is important, the domain. We definitely know that x and h must be positive, but we also have some constraints. We have some limitation because of that 48 square feet of materials. That we can see x in the denominator for x is positive, it's fine, but 48 minus x squared must be always positive too, okay? Because I can't have negative numbers, because if this numerator is negative, the whole h will be negative. And solving this equation, I have to factor out okay? And I can draw a number line because it's quadratic equation. One of the number is negative square root of 48 and positive square root of 48, right? This will give me negative, this will give me positive. And looking maybe at this, I mean, we have to test the sign like we were doing for the critical points. But I see that this is quadratic function, parabola, open down. That means that's the graph of this function, okay? Or I can possibly avoid this. Oh no, I can keep it because I would like to show you this is positive and this is negative. That means I can only take numbers between, not even including this because this will give me 0, between negative square root of 48 and positive square root of 48, which, however, even the negative square root of 48 is not really good because we have to cut this in half because we're only looking at positive numbers. That means this is actually the domain. And I did type this for you. It's from 0 to square root of 48. That means if our numbers are outside this interval, especially on this, we can't accept it. Then maybe we don't have the solution, okay? And 48, square root of 48 is just almost 7, right? Because it's square root of 49, it's 7. Okay, we do have domain. We have our function. Let's differentiate. That means derivative of 12x. Oh, I have my next slide. Let's differentiate. Derivative of 12x, of course, is 12. Derivative of negative 1/4 x cubed, it's 3x squared over 4. And negative stays 12. Okay. And now we have to solve this equation for the critical points. Okay. For critical numbers, which means the whole formula must be 0. And what I can do, I can maybe just solve it for x squared because it's not inequality, it's the equation. I can subtract 12 and multiply by negative 1, and now I can multiply by 4, which will be 48, and divide by 3, it's 16. Okay, that's a nice number. X squared equals to 16, x equals to 4, and this is fine, but not this one, of course, no. Okay, and then what I have to do, I have to check if at 4, okay, my derivative of the volume is changing the sign from positive to negative because that's what I want. I'm looking for the maximum. But let's see. If I will substitute to my, this is my derivative. Remember testing. I can substitute like huge number. Yes, 5, 6, 7, 8, 9. That means this will be squared and it's negative. That means definitely this part will be bigger than 12 and having negative will be negative. And if I will substitute 0, this is gone, 12 stays positive. Okay, that means my function volume behaves like that, increasing, decreasing. It's a local maximum, but this is the only number because domain was, I can come back. No, I don't need to come back. Domain was an open interval. Why I'm writing 18, I don't know. Right? That's we can't really test the endpoints 0 and square root of 48 because they are not in the domain. That means this is the only maximum value. When x is 4, okay, when x is 4, volume of that box is a maximum. That means what are the dimensions? Because we need 4 by 4, that will be base. We also need, oh, we don't need this. Don't worry, we don't really need, we don't need that part because we don't have open, a closed interval. We just have to find h. And do you remember what was h? 48 minus x squared over 4x, I think. And we have to find h if x is 4. 4 squared is 16. 4 times 4, 2. Yeah, I think it's 2, but let me just 32 over 16, yes, it is 2. Thank you. That we have, I did type this, but we have 4 by 4 by 2. That we can see not really tall box, because 2 is the height. Yeah, like that's the maximum. I mean, that's the height too, which indicates that if the box is lower, the volume is bigger. Yeah? And of course, that's the lowest that we can get for the height. And always, yeah, look, that's what I said. Maybe we can ask just for x, like just for length or width, or we can ask for height too, or we can ask completely for the whole dimensions. Okay, and let's follow the same steps and let's solve the other problem. Yeah, I have this, but we don't have to compute this. 4 by 4 by 2. Okay. Find the point on the line y equals 4x plus 7 that is closest to the origin. Okay, that's what we can see. I can even draw the line because given information is just the line, right? Because I typed the solution. Let me draw it here. 4x plus 7. That means the line looks like that. 7 is the y-intercept, and negative 7 over 4 is the x-intercept, because if I substitute, I have 0. And now we're looking for the point somewhere that is closest to the origin. Probably here, x and y. Okay, that's me looking for x, y. I don't know, yeah, it's not easy to guess, but it's telling me the closest. And of course, I did show you what is required, but what we have to do, we have to find the shortest distance, right? The shortest distance from 0, 0 to xy. And what we can do, because and we can see this is the distance formula. Do you remember the distance formula? Okay, make sure that you do for your weekly assignments or the midterm, okay? Distance formula, x sub 2 minus x sub 1, y sub 2 minus y sub 1. Okay, I think that's one thing. And of course, addition and square, yes, like based on the Pythagorean theorem. That means we have to minimize minimum of the distance, yeah, because we have to, the closest distance on the line. Okay. But one thing what I would like to tell you that will simplify this question, because we can see distance is the square root of something, which we will put the stuff inside in a minute. And we know that in order to find the minimum or maximum, we have to differentiate. That means we don't really want to keep that square root all the time, because this will be maybe too complicated function. But we may think, and in terms of minimizing the distance, which is minimizing the square root, it's just enough to minimize the quantity inside, right? Because if I will have square root of 4, of course it's 2, but it's square root of 4. That means this number is 2 because I have, everything depends on the number inside. If I would like to have a lower number, I will put lower number inside. If I would like to have even lower, like this one is 1 point, I don't remember, 1.8, 1 point, I think it's like that. That means if I would like to minimize the entire value, which is this, I have to minimize the number inside, right? That means what I will do, I will kind of square to keep my left and the right hand side correct. But my point is that we don't have to minimize the entire distance. We can just call the function d squared, and we can minimize the number inside, okay? Because that's helpful. Okay, now let's put the values. As I said, one point is x and y, another point is 0, 0. That means x minus 0, y minus 0, okay? And of course, we don't need that zeros, oh, too fast. Of course, I will not rewrite the zeros again. X can stay, but we also know that one of the points is that we have to rewrite our function in terms of one variable. That means y, xy, y will be this. Like I did. It's nice and given right away. I don't even have to rewrite anything. And I have x squared and I have y squared. And y is 4x plus 7. Okay, nice function. This function again represents the inside quantity. And we can see for this one, theoretically, we have no domain. It could be any number. We know that it's somewhere here, yeah, but theoretically could be any number. That's we have no constraints. X could be any real number. Okay, now what we can do? Oh, I did expand this, but we don't have to. Maybe we can take the function like it is and use the chain rule for the derivative. But I think I did this. Oh, a little bit too big numbers, but that's okay. I copy x squared, and then I FOIL this because it's 4x plus 7 times 4x plus 7. When you multiply everything, when you FOIL, you have 16x squared, 49 at the end, and 4 times 7 and times 2, because we will have double from the foiling, from multiplying, distributing. 28 times 2, 56x. Okay, and let's combine x squared and 16x squared. Okay, that means this is a good function for the derivative. So because again, nice order, no quotient, no ratio. I mean, no product, no quotient, and not even chain rule. You could take this function and differentiate derivative if you like, or we can take this one. Okay, now we need the derivative. Derivative of the function is simply 17 times 2x, 34x, and 56. And for the critical numbers, this must be 0. Subtracting 56 and dividing by 34 and dividing by 2 each numbers, we have negative 28 over 17. Okay, not friendly number, but that's how it is. And I think this number will be placed here. That means my graph looks like reasonable. I think it's because 28, 17, 17, I'm just trying to think the number. This is 17 times 2. Okay, that means this is less than 2. That means, and this is also less than 2. Okay, that means this makes sense. The quantity, I mean the coordinates x is negative 28 over 17. Okay, and we have to find the point. That means we have to, oh, hang on, we didn't test if it's the minimum. Oh, wow, too fast. I'm assuming, but negative 28 over 17. And my function was d squared, and I'm testing the derivative. This is derivative, right? That means if I will put, let's say 0 on this side, 0 will give me only 56 positive. And if I will put huge negative number from that interval, huge negative will give me huge number, and plus 56 will not change, will be negative. That means my d squared, my distance, behaves like that, decreasing, increasing. And of course, this is minimum. It's a local minimum, but that's the only minimum value of the function. And this is the first derivative test. Right? Remember to check that. That means, yes, this is a good critical number. It's giving me a minimum. And now, in order to find y, I have to copy 4x plus 7, but instead of x, I have to substitute that number. And we can leave it like that. It's too many calculations. I mean, we can try, just maybe you can help me. 4 times 28 over 17, and maybe I can multiply 7 by 17 to have the common denominator. 4 times 28, 112, thank you. Oh, somebody's helping me, really nice. And what is 7 times 17? Thank you, Ryan. 7 times 17. Yes, wow, good. Okay, I hope you're not using the calculator. I was trying to add 70 plus 49. You're right, it's not 119. And then it's just 7 over 17. Okay, at least it's positive. We can see, makes sense. Maybe my function is a little, but this will be 7 over 17. Okay, that will make sense. That's the x value, that's the y value. But probably for this question, we will just ask for the x coordinate. Or maybe for both, depends. Nothing, it didn't take long. Okay, but remember the message from this slide is do not carry the entire distance formula, focus on the inside. Okay? It's the same thing. I mean, we're satisfying the question. Okay, let's keep moving. I have another one. Example number 3. A farmer has 24 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? That means what we have to do in this question? Who can tell me? Maximize what? The area, simply the area. Okay, thank you. Yeah, that means we can, it's good. You can recognize. That's really good. Okay, for this one, I don't have a solution. I will write for you. That's means what we have. Let's put this river and his field. Okay, I don't know, maybe it's a little bit different, but let's make it this one. And we may have x, and y. Okay, that's rectangular. My river is a little bit, but it's straight river. Okay, and what we know, given information are 2,400 feet of fencing. That means fencing means like a parameter, x plus y. Let me do this y. I mean, doesn't matter. That we have 2y plus x, it's 2,400. Yes, do you agree with this? Because it's fencing. That means he only has this. That means that's the condition, that's the constraints. 2y plus x equals to 2,400 feet, but I can skip the units for now. Okay, now that's the given information. Now what we have to do, the required information, area maximizing. Okay, that means who can tell me what's the formula of the area of this rectangle? Yeah, just simply length times width. Yeah, thank you, x times y, of course, x times y. But we really like to have the area just in terms of x. Oh, actually, that was good, because I'm trying to keep the x and trying to make easier for you. Let's put 2x plus y. Yes, and we will solve, because we need the formula for y taken from the given information. And I wanted to solve this equation for y easier than like for x, dividing by 2. That means 2,400 minus 2x. Okay, that means I was right at the beginning. Okay, 2,400 minus 2x. That means this is the nice, I can maybe write this. Yes, we will substitute this here. 2,400 minus 2x. And let's make a function. Let's distribute 2,400x minus 2x squared. Really nice. One variable, and this is my area in terms of x only. Having actually this constraint, we do have some limitation for the domain, because we want 2,400 minus 2x to be positive. All right, we can't have y negative. And solving this will give me some constraints, actually negative. Dividing by negative, I have to change the inequality. That means we can see x must be smaller than 1200. And of course, positive, never negative. That means this is nice domain. Just positive numbers, not greater than 1200. Okay. Okay, let's differentiate. Derivative will be 2400 minus 4x. And derivative must be 0 for the critical points. X is 24 divided by 4 is 600. Please, of course, always watch my arithmetic. 600, that's my critical number. X, 600. Let's test. I can pick 0, and this is my derivative. Maybe I can use different color, blue. If I will put 0, 2400 minus 0, positive. And if I will put huge positive number, it will give me negative, negative. That means my function area behaves like that, increasing, decreasing. This is definitely maximum. And again, it's the only number that I can use. That means this is the absolute maximum on that interval. 600. That means x is 600. Who can calculate y? Because we need a dimension. Oh, 1200. Okay, this is y. 2400 minus 2 times 612. Of course, yes. Yeah, I'm just... Okay, that means that my actually picture looks good, right? Because it's 600, 600, and 1200. Because I did copy from your textbook a few pictures I can show you. Because we don't know, maybe this rectangle should be really slim. Yeah, we don't know what dimensions will give me the largest area. That means 600 by 1200. And I can show you this. Yeah? We can see 100, 100, 22, 10, 100, 10, 100, 400. Yeah, we may have different shapes, but actually this one was 600 and 1200 and 600. That's the maximum. Having, of course, that amount of fencing. Pretty nice question. Okay, let's keep moving. Oh, price. That's another example. Did I solve this? Oh, okay, I did type, because some of them I was typing, some of them I didn't. But let's see. A rectangular storage container with an open top, again, open top, no top, is to have a volume of 10 cubic meters. Okay. The length of its base is twice the width. Okay, that means if this is x, can you tell me how can I label length? It's of course 2x, thank you. That's, you can see we can avoid extra variable. Okay, now the material for the base cost $10 per square meter. That means to build the base, of course, must be stronger, costs $10 per square meter. The material for the sides costs $6 per square meter. That means the sides are a little bit cheaper because they don't have to be as strong as the base. Find the cost of the materials for the cheapest such container. Okay? That means we can see cheapest. What do you think? What we have to do? Maximize or minimize? Minimize, of course. Minimize the cost. Minimize the cost. And the cost, in order to get the cost function, we have to go through the materials, which means through the surface area, because I have to have the amount of the material that I need to build the base and the sides. And of course, always remember, include the prices. Okay, let's start. Given, required. I do have labels, but we did, even without my typing. Okay, that's what is given. Given is volume. And because volume, it's 10 cubic meters. And required, have to be careful because I don't remember. I do remember, but I don't remember the order. I can maybe ask you a few questions. That means required, as I said, is the surface area. Right? And can you tell me if you agree with my formula? The surface area will be length times width. Okay, that's the base. Okay, let me do something like that. And then 2 times width times height, right? Because this will be this side. And then 2 times length times height, which is the back and the front. I don't want to mess up the 3D picture, but we know what it is. That means this is definitely H. We do have the sides, right? We do have the sides and the bottom. But let's put X and H. That means length times width is simply, it's simply X times 2X, 2X squared. 2 times W is X, H is H. H will stay. And then length is 2X, 2 times 2X is 4X, and H will stay. That means this one is a little bit better because we have only X and H. We do have to rewrite in terms of one variable. Okay? That means always remember the given information will give us some relationship, some hint. Because what we will need, we will probably keep X, but we have to get H. But before we start, okay, I did simplify because this is XH and this is XH. I did add together, 2 plus 4 is 6. That means now looks better. I will keep, of course, 2x squared plus 6x, but H I have to rewrite. But as I said, this is the surface area. That means this is the amount, 2x squared. It's an amount of the material that we need to build a base. 6xh is the amount of the material that we need to build a sites, yes, the walls of that box. We have to minimize the cost. That now we have to incorporate the prices. Okay? That means in order to define a cost function, I will take this amount of the material, 2x squared, and multiply by $10. Okay? That's what I was, actually I can keep that blue because that's the sides. That means this is the side and this is the base. Okay? And my colors corresponds to the prices. That means now we can see the side, that's the amount of the material multiplying by cost. If I will need like 20 square meters, I will multiply by $10, I will pay 200. If I will need 40 square meters, I will multiply by $10 and I will pay 400, right? That means that's the amount multiplying by price. Amount multiplying by price. Respectively, I'm keeping the pricing, what was given. Okay? That means that's important because what we do, we sometimes forget about the prices. And then we have 20, I can skip dollars, 20x squared, and 36xh. That means this is my function. It's still not a one variable, but this is the cost function. Okay? Please remember about dollars. Okay, now who can tell me the formula for the volume of that box? Because we have to find the formula, compare with the 10, solve for H, and substitute here. Okay. What's the volume of the box? We did have the volume today, I think. Yeah, somebody type. I mean, almost everybody. Yes, thank you, Joe. Which in our case, okay, length times width times height. And length times width times height is 10. But we will not use LWH. We will use 2x times H. Oh. I am too fast. Oh, actually, I'm not too fast because I'm still keeping length times width times H. Dividing both sides by length times width, I did solve for H. That's what I want. But now my length is 2x and my W, my width, is x, 2x squared. Okay, nice. And I'm taking this and substituting here. Okay, let's see what we have. We have this. I will put 36x times 5 over x squared. Okay? And 36 times 5, it's 180. X and x squared is cancelled out, only x stays. Okay? That means that's my height. Height, and this is height. Okay. Okay, we do have a function cost in terms of one variable. It looks good. I can't avoid the quotient. Yeah, of course, we can use the power rule, but we can see this is the simplest form. That means now, for the critical points, for the minimum, we need a derivative. Derivative of 20x squared is 40x. And we remember derivative of 1 over x. 1 over x is negative 1 over x squared. Constant stays, 180 stays. But derivative, please remember, derivative of 1 over x is negative 1 over x squared. Okay? Okay, and now, that means this is my derivative, and derivative must be 0 for critical points. I will get common denominator, x squared. I will multiply 40x times x squared. I have this. Right? And now we remember critical points are the zeros from the numerator and denominator. Yes, we remember that. But since x cannot be, because x and h, it's positive numbers and they cannot be 0. I can't have length or width 0. That means I can only focus on the top. Okay. And then let's add 180. Oh, of course, my typing is, where can I write? I can write for you extra steps. I am adding 180. Of course, right away I can divide by 10. And x cubed will be 18 over 4. X cubed is 9 over 2. And now simply cube root of 9 over 2. I think we can leave it like that. Oh, it's a weird number, but it is cube root of 9 over 2. We have to test it. Let's see. Cube root of 9 over 2. That's the x value, which means the length, width, will be this value. But let's check the derivative of the cost. I can definitely pick 0 from that side. Where is my derivative? I think this one looks good. That's derivative. I am going to test this. I don't have to test denominator because it's always positive. Okay? That means if I will put 0, I will have negative 180 only, negative. And if I will put huge number, any number, x cubed, cube that number, positive. That means the cost function behaves like that, decreasing, increasing. Excellent. It's a minimum value. That means this is the x value for the cost to be minimum. And I think I'm worried that my question asks for cost, which what we have to do, we have to copy a cost function. Do you remember? That was the cost function. And instead of x, I have to substitute this weird number. Okay, but don't worry, we will not ask you this. We may ask you for this, for the x value. Okay, that means x value, remember, cube root of 9 over 2. But we will not ask for this because we don't have, like, let's say, I don't know, time or I was going to say calculators. Because now you can see I did put, instead of x, I think this one. I have to put cube root of 9 over 2 and I square cube root. That's crazy number. No. I don't want to even look for this. Okay, but please remember, make sure that you know how to find the x value, right? Which will be the width. Length is twice and height is the other formula. Okay? But we can just leave it. I think asking for cost, that's crazy. Okay? But I can even. But this will be, if you can use the calculator, this will be a minimum cost, okay? With this value. But I can leave it like that. Okay. the message on this question is, don't forget the dollars, $10 and the $6. And then follow the same steps. Function, one variable, derivative, critical points, testing, and that's it. Okay, and I do have 1 or 2 more problems. Oh, I have 2 multiple choice, and we will be done. Oh, which actually this one is similar, but let's do it. Find the x coordinates of the points on parabola x squared minus 3 closest to the origin. Oh, probably you can do it. That means what is given? Given is just this. Okay, required is a distance. Yes, closest. We have to minimize a distance. X, shall I put the formula? X2 minus x2 minus x1, y2 minus y1 squared. But we remember, do not focus on the entire formula. Just focus and minimize or maximize, depends what they're asking, on the inside value. Okay. Shall I draw this situation? Let's see. X squared minus 3. That means this is parabola x squared shifted 3 units down. This will be, I believe, square root of 3. Okay, and we're looking for, oh, do you see something? We will probably have 2 points because it's symmetric. That's origin, 0, 0, and I can call them, it should be symmetric, but we can see that the same distance, the closest distance is somewhere here, but we will get 2 points. That means probably the answer, actually, do you know which answer is good? Probably E. However, maybe this. No, but this is, you can see maybe the square root of 3 will give me the shortest distance. Or maybe not. I think this one will be shorter because it's not a circle, will be the same. Yeah, that means probably E, definitely not this. Yeah, because we can see we have to have 2 options. We can see how nice question. If we're really thinking, we can be more efficient. Okay, but let's do it. That means what I have? I have my distance squared. X minus 0, the same thing actually, y minus 0. That means the distance squared is x squared plus y squared, but I don't need 2 variables. And in this case, okay, y is equal to x squared minus 3. X squared and y is x squared minus 3. Shall I expand this or shall I use the, let's use the chain rule for the derivative, okay? Like, because we did solve differently the other one. That means derivative is x squared is 2x, and now derivative of x squared minus 3 squared, it will be 2 times the quantity x squared minus 3 times derivative of the inner function, which is 2x. Yes, that's my chain. Let's simplify. 2x. 2 times 2x is 4x. Oh, I think I still have to, wow, derivative it's not as easy as I will expect. 4x cubed and minus 12x, right? Let me write here, derivative of my function is 4x cubed and minus 10x. Okay, that means derivative is 0 if and only if 4x cubed minus 10x is 0. Let me put the dividers. I can factor out 2x. X something is, it's everything correct? Because I don't know if I like x squared, no. 2x squared minus 5. Okay, it is correct. then this is 0 if x is 0. Now let me factor out one more time. It will be, oh, shall I factor out? No, I think you will like it this better. This is 0 or this is 0. And then solving for x squared, I have 5 over 2, and then I have positive, negative square root of 5 over 2, okay? But what we will need to test this. That means critical numbers are 0, negative square root of 5 over 2, and positive 5 over 2. And my derivative behaves like that. What I'm testing? I am testing this formula. Okay, that means if I will put huge number, I will have positive. And then I know that they alternate because nothing is like repeated, because from x squared we have 2 of them. Okay, that means my distance function behaves like decreasing, increasing, decreasing, increasing. That means that's the minimum and that's the minimum. 0 is giving me maximum. And that means 0 is not a good number. And of course, no question mark, this is the correct answer. Yes, the points, that means not this one, the negative square root of 5 over 2 and positive square root of 5 over 2. We almost got an answer, almost at the beginning, right? But you can see how nice it is to draw the situation and remember the distance. Even if it looks complicated, it's not. Okay, let's do one more. Okay. What we have here. According to the postal regulations, a box is classified as an oversized if the sum of its height and girth, oh, I don't even know that word, but of course I learned that it's girth, I don't even know girth, how to pronounce this. The height and the parameter of the base exceeds 108. That means if it's longer than 108 inches, 108 inches, then it's oversized. I can write maybe this. Given information is telling me the sum of height and the parameter of its base, which we do have a square base, will be base, 4 times base. I don't have to. Base, 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 base. Okay? The side. Okay. Okay, that means this one actually, the sum must be smaller, but I can put equal to, of course, everything will be smaller. Okay. For a box that has a square base, it's not oversized, and has a maximum volume, find the length B of one side of the base. Okay, that's we can even see, maximize the volume. Required information, volume. Who can give me the formula for the volume using these labels? Who can give me the formula for the volume? Thank you. Yes, B squared times H. Who can tell me what H is equal to? Because we can see that's probably the exam type question. We have to be like efficient. What is H? Yes, thank you. 108 minus 4B. That means B squared, 108 minus 4B. 108 B squared, 4B cubed. Okay, who can tell me derivative? That means this is my volume, and we have to maximize. 108 B squared minus 4B cubed. Who can tell me the thank you? Because we have to solve it fast. 12 B squared. Excellent. Now, volume is 0 if this is 0. Okay. We can factor out, we can definitely factor out, okay, let's factor out 2B for now. 108 minus 6B, right? We can do this. And then B is 0, which of course we can't accept 0 because B and H must be greater than 0. Who can solve this one? 108 minus 6B equals to 0. Who can tell me what is B? 108 divided by 6. It's 18, yes, yes, because it's the other way, it's the other way. It's 108 divided by 6, yes. Okay, Ryan, yes, no, okay. That we do have, of course, 0 is not important at the moment, but we do have 18, and I'm sure that's the answer, but let's wait. Always make sure that we, what is the formula? Maybe this one, the formula that I'm testing, I can possibly use. I always like the product. Okay, if I will put 0, I will have, no, I can't put 0. Let's put 1 because 0 will give me 0. If I will put 1, this is positive, and must be negative, right? Because if I will put huge number positive, this will be positive, but this will give me negative. And volume is increasing, decreasing. This is definitely a maximum. Okay, as we can see, doesn't take, if